Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions from October-November 2022 paper 1. In today's lesson, we will start from question number 11 and we will discuss next 10 questions. In the last video, in part 01, we have done from question number 1 to question number 10. And for the solution of those questions, you can go to the channel and you can check for part 01 and you can find detailed solution about first 10 questions. And today's lesson, we will discuss next 10 questions. Let's study together. Let's improve together. For question number 11, we need to find out which diagram shows a couple formed by two forces, each of magnitude capital F acting on a rod. So first of all, we need to understand when two forces, they will form a couple. Forces will form a couple if the forces, they have equal magnitude. So the first condition is that equal magnitude. So magnitude of forces has to be the same. So we can say this is condition 1. And the second condition is that opposite direction, means forces need to act in opposite direction. So the resultant force on the rod will be equal to 0. And third condition is that there must be perpendicular distance, or simply we can say there must be separation between line of action of forces, separation. So we can use these conditions and we can try to find the answer. The first one is not possible because forces are acting in the same direction. This is not possible because the forces are not in opposite direction, because this force is at an angle, so they are not in opposite directions. So this is not possible. This is also not possible because forces are not in opposite directions and there is no separation between that line of action of forces. So this is also not possible. So this one is the answer. Because torque of a couple, when forces they form a couple, they have pure rotation. There is no translation. So they have pure rotation. So very important one. So then body will just rotate. So there will be pure rotation when the forces they form a couple. So the answer for this question is D. For question number 12, it is given to us. A student states that if an object is in equilibrium, the sum of clockwise moments about point X is equal to sum of anti-clockwise moments about a point Y. So in this case, object cannot be in equilibrium. Object is in equilibrium if sum of clockwise moments and sum of anti-clockwise moments about the same point is equal to 0. So then object can be in equilibrium. So this object can be in equilibrium if X and Y they are the same point. So we can say if X and Y they are the same point, then it is possible object can be in equilibrium. So question is asking us which condition could make the student's statement correct. So condition is that X and Y they have to be the same point. If you look at option A, this is not possible because this is telling center of gravity of the object either X or Y. This is not possible. Either X or Y is the pivot of the object. This is also not possible. X and Y are at opposite ends of the object. This is also not possible because this is telling you these are two different points. So that cannot be the answer. If you look at option D, it is given to us X and Y are the same point on the object, and this one is possible because if an object is in equilibrium, sum of clockwise moments and sum of anti-clockwise moments about the same point, or you can say about any point, has to be equal to 0. Means you need to talk about the same point. It cannot be about two different points. Then object cannot be in equilibrium. So the answer for this question is D, about same point, because condition is that if object is in equilibrium, this is principle of moment, in equilibrium, then net moment about any point has to be equal to 0. So we can say net moment about any point has to be equal to 0. Net moment about any point has to be equal to 0. Or simply we can say about same point same point on the object, about same point, sum of clockwise moment, so we can say sigma sum of clockwise moments, it has to be equal to sum of counterclockwise moments, or simply you can say anti-clockwise moments about the same point. So this is the point you need to understand. For question number 13, it is given to us a uniform rod of length 30 centimeters and weight 5.2 newtons is attached to a wall by a hinge at one end. The other end of the rod is supported by a wire so that the rod is horizontal and in equilibrium. The wire is at an angle of 40 degrees to the horizontal. We need to find out what is tension in the wire. So first of all, we need to understand there is a tension in the wire. That's the reason this is in equilibrium. And this rod is uniform. So it means its center of gravity is acting at the midpoint of this rod. So we can draw the line here. So the force of gravity is acting here. And the distance of this one is 15 centimeters. So the distance from the pivot to this point, we can write down here. This distance is equal to 15 centimeters. And this tension in this wire, it has two components. So it has one vertical component. So we can draw here. So it has one vertical component and also it has one horizontal component that is acting this way. Now, in this case, we need to understand moment. If we take our pivot point here at the hinge, then the moment due to this component of tension will be equal to 0. There will be moment only due to this component of tension. And this component of the tension is T sine of 40 degrees because this is not with angle. The component with angle is cosine and the other component is sine. So this is T sine of 40 degrees. Now simply we need to take moment about this point and we can calculate value of T. So in this case, due to vertical component of tension, this moment will be anti-clockwise. And due to weight of the rod, moment will be clockwise. So this moment will be clockwise and moment due to tension, this will be anti-clockwise. And this rod is in equilibrium. It means these two moments are equal. Means if we take moment above this point, clockwise moment has to be equal to anti-clockwise moment. So simply we can write down in this case, T sine of 40 degrees means this is our anti-clockwise moment multiplied by the distance from the pivot, perpendicular distance, and distance is 0.30 and this one has to be equal to clockwise moment, that is W times W is given, that is 5.2. So simply we can write down 5.2 times distance, that is equal to 0.15 means the perpendicular distance, and from here we can find out value of T. So T will be equal to 5.2 times 0.15 divided by 0.30 times sine of 40 degrees. And if we solve this one, our answer up to 2SF will be equal to 4.0 newtons. So the answer for this one is B. So this is how you can figure out. So the answer for this one will be B. For question number 14, it is given to us water is pumped through a nozzle at the end of a hose. The nozzle has a circular cross section of diameter 50 mm. A mass of 100 kg of water takes a time of 2.0 seconds to move through the nozzle. The density of water is 1000 kg per cubic meter. We need to find out what is speed of water in the nozzle. Now, first of all, we can sketch circular cross section. So imagine that this is the circular cross section and water is passing through this nozzle. So this much water is passing through this nozzle. And if we look at this cross sectional area for 2 seconds, how much water has passed? 100 kilogram has been passed. Now we can extend this one. Imagine that this is a cylinder. Means when first time we look at this one, at time t is equal to 0 second, some water passed through this cross-sectional area and that water has reached at this point. And in this time, the amount of water passing through this point is equal to 100 kilograms. So in this case, simply we can say this distance traveled by water, let's say this distance is equal to d. Now simply we can say in this case, mass will be equal to density times volume of this cylinder, this imaginary cylinder. Let's say cross-sectional area of this one is A. So we can rewrite this one. We can say rho times A. So volume is equal to A times D. Now if we divide both sides by time, so let's say we divide this side by time and also we divide this side by time. Now you can simply see from here, distance traveled over time taken, this one is equal to speed. So we have mass over time. This is simply is equal to rho times A times speed. So this is the speed of the water. And for this question, we need to calculate speed of water. So we can simply say mass over time, time taken for the water to travel from here to here. This one has to be divided by density times cross-sectional area. And now simply we need to plug in values. In this case, we have mass that is equal to 100 kgs. Time taken is equal to 2 seconds. And density of water is 1000. And cross-sectional area we need to calculate. So we can take pi by 4 d square. Diameter is 0.05 and we need to take square of this one because this is in millimeter. I just converted into meters. And now we can solve this one for V. If we solve this one for V, up to 2 SF, our answer will be 25 meters per second. So the answer for this question is C. A beautiful question you need to visualize. For question number 15, it is given to us a solid wooden cube rests on a horizontal surface. We need to find out what gives the pressure exerted by the weight of the cube on the horizontal surface. So the best way to answer this question is we can sketch first of all cube. So you can imagine that we have a cube. So this is, we can simply imagine is a cube and we can complete this one. So you can see this cube has all the sides equal. So we can say the length of one side, let's say is L. So this also the length of this side is L. And in this case, we need to find the value of P. And P is equal to force over area in contact. So F over A. F in this case is equal to weight of the cube. So we can say mg over A. And mass of the cube we can write down in terms of density and volume. So we can say density times volume times G divided by A. But we need to understand the volume of this cube. The volume of this cube is just simply L cube times G, and cross-sectional area of this one means cross-sectional area means this area in contact. And this area is equal to L square. So simply we can cancel this L square with this L cube. So we will get rho L times G. And this is the value of the T. If you look at given options, for option A, it is given to us. It is the product of acceleration of free fall and density of the cube. Density of the cube. So it means volume is missing and cross-sectional area that is also missing. So that is not possible. So it's simply telling you density and G, but L is missing here. So it cannot be the answer. So this is not answer. Product of acceleration of free fall. So this is simply, in this case, they told you this is rho times G. So that's not possible. This is telling you acceleration of free fall, density and side length. So this is telling you P is equal to rho LG. And this one is possible. So the answer for this one is P. Product of acceleration of free fall, density and area of one face of the cube. And that is not possible. Density times area times G, this is wrong. Product of acceleration of free fall, density and volume of the cube. So this is telling you P is equal to rho times V times G. Actually, this is the mass of the cube. So this is not P, this is the mass of the cube. So this is not possible. So D is wrong. This is also incorrect. So the answer for this one is B. For question number 16, we need to find out which expression could be used to calculate power. So simply we need to understand what is formula for power. First one, this is not possible because power is equal to I squared times R. So this is not possible. Power also, this is equal to work done over time. So we can simply say power is equal to work done over time, and work is equal to force time displacement over time. So option B is possible. Current time, resistance square, not possible. Weight over time, not possible. So the answer for this question is B, quite straightforward. For question number 17, it is given to us a bungee jumper jumps from a platform and is decelerated by an elastic elastic bungee cord as shown in the figure. When the jumper makes the jump, his initial gravitational potential energy is converted into kinetic energy and also into elastic potential energy in the cord. At which part of the jump are all three types of energy non-zero? Mean this person has kinetic energy and also has GPE and also EPE due to extension in the cord. So simply we can write down, first of all, if this person has GPE, there must be some height from the ground, and that will be always true. He will be higher from the ground. And kinetic energy will be if the person is moving. And elastic potential energy is possible when the string is extended. There is extension. Now, if you look at this one, now in this case, the string is not extended. So in this case, this person has GPE. So we can say this person has GPE. And this person has kinetic energy, but this person has no EPE because there is no extension. EPE is equal to 0. So means in this position, it has only two forms of energy. Now look at given options and we can try to find the answer. So EPE is possible when the string is extended. So this is the point only you need to understand. So let's try to find out the answer. On the platform before the jump, at this point, person is at rest, string is not extended. So the person has only GPE. So we can simply write down here, person has only GPE. On the way down, before the cord has started to extend. So this is the scenario when the cord has not been extended. So person will have GPE plus KE, kinetic energy. On the way down, as he decelerate means that it will decelerate when the string is extended. So in this case, person will have GPE plus KE and plus EPE. Decelerate means that the string has been extended. So the string is pulling upwards. So there is tension in the string that is pulling upwards. So this can be the answer. So C is possible answer. At the bottom of the jump, when he is stationary. So at the bottom, so we can say person has GPE if we take ground as a reference, and also the person has EPE but no kinetic energy because the person is stationary at the bottom. So the answer for this question is C. I hope this one is clear to you. So let me explain you this one with the help of animation. I have prepared one beautiful animation for you to visualize the bungee jump. So you can see here, first of all, here bungee jumper is not moving, is at rest. So you can go to the next stage. You can see here now it's moving down. So at this point it has kinetic energy and GPE but no EPE, and at this point it has all three forms of energy. It's slowing down, it's moving down, the speed is slowing down. It means string has been extended. So it has EPE, it has GPE and also kinetic energy. And if we go to the next one, at the bottom only EPE and GPE, and then it starts coming up, speeding up. When it is speeding up, and also in this case it has three forms of energy. It has EPE because string is still extended, and KE and GPE, and still rising, and finally here. This is what you need to understand about bungee jump. I hope this concept is clear to you. For question number 18, it is given to us an object is displaced horizontally to the right in a uniform vertical gravitational field. Which statement describes the change in the gravitational potential energy of the object? So first of all, we can draw a ground. Imagine that this one is the ground. This is the ground. And we can draw some arrows to show direction of gravitational field. So imagine that this is direction of gravitational field, and this gravitational field is uniform, and this is vertically downwards. And now we can also draw, in this case, one dotted line to show we move object horizontally. So this is at the same level, height is the same. Now we can imagine, in this case, we place a mass here. Let's say we place mass at this point, and we move this mass to the right to this location. Now you need to understand, in this case, let's say this is position A, and this one is B. So in this case, is any work done by gravity or not? You will say work done by gravity is 0 because gravity is acting vertically down, so the work done by gravity is 0. If work done by gravity is 0, it means there is no change in gravitational potential energy. Otherwise, simply we can understand with the help of this one, gravitational potential energy will change when there is a change in height. As in this case, there is no change in height, it means the change in GPE will be equal to 0. So now we can look at given options and we can try to find out the best possible answer. It decreases in direct proportion to the displacement? No, it does not decrease. Actually, it doesn't change. Option B, it does not change with the displacement. This one is right because delta H is 0. So the answer for this one is B. But if you go to C, it increases. That is also wrong, incorrect. It increases. That is also incorrect. So the answer for this one is B. Because in this case, there is no work done by force of gravity because gravity is down, displacement is vertical. So the work done by gravity is 0. It means there is no change in gravitational potential energy, or in a very simple way, simply you can understand there is no change in height. So it means that there is no change in potential energy. For question number 19, it is given to us a copper wire of length 3.6 meters and diameter 1.22 mm is stretched by a force of 37 newtons. The wire obeys Hooke's law. The Young's modulus of copper is given, that is 1.17 times 10 to 11 Pascal. We need to find out which extension is caused by this force. So quite straightforward question. Simply you need to use Young's modulus. So if we start with Young's modulus, so Young's modulus is equal to stress over strain. So we can say stress over strain, and stress is equal to force over cross-sectional area divided by strain, means delta L by L. So if we simplify this one, we will get FL divided by A times delta L. But question is asking us to calculate delta L. So we can rearrange, so we can write down in terms of delta L. So delta L will be equal to, in this case, FL divided by A times E. And now simply we need to plug in values, and you need to be careful with units. So force is given, that is equal to 37 newtons. L is given to us, that is 3.6 meters. We need to divide by Young's modulus, that is 1.17 times 10 to 11 pascals, and cross-sectional area pi by 4 d square. So the diameter is given, that is 1.22 times 10 to negative 3 square. And now simply you need to use your calculator and you can find value of delta L. If we do calculations, value of delta L will be equal to 1.18 mm. So the closest answer to 1.18 is 0.97 mm. So the answer for this question is C. For question number 20, it is given to us a spring has spring constant K. The spring obey Hooke's law and experience extension X when a force F is applied to it. The resulting elastic potential energy of the spring is EP, E sub P. The diagram shows two of these springs joined together in parallel and hanging from a fixed beam. What is extension and total elastic potential energy of this arrangement when the same force F is applied? So first of all, we can imagine a spring. So you can imagine a spring. Let's say we have this unextended spring, and the spring constant of this spring is given, that is K. And now we apply force on this spring. So when we apply force on this one, this is extended by certain amount. It is extended by X. And elastic potential energy stored in this one is EP. But now if we look at this given arrangement, when we have two springs, we apply force F here. So the force acting on this one, force will be distributed, means it will be divided, it will be shared by these two springs. So the force on this one will be F by 2 and force on this spring will be also F by 2. Now force become half. F is equal to K times X. This remains constant. If the force become half, it means extension also become half. Means the extension of this spring will be X by 2 and extension of this spring also will be equal to X by 2. Now we need to calculate total elastic tension energy of this arrangement. So simply we can say EPE nu. We will say EPE nu here. EPE nu will be equal to 1/2, mean EPE stored in this spring plus in this one. So we can say 1 by 2. We have force, that is F by 2, and extension in one spring, that is X by 2. And we have two springs. So again we can rewrite. So we have F by 2 and we have X by 2. So this is energy stored in each spring. So if we add these two together, so simply we can multiply by 2. So we have, in this case, this is 1/2, and we have this is F by 2, F by 2, and here we have this is X by 2. So simply in this case we can cancel this 2 with this 2. Simply we can cancel. So we left with 1 by 2 F times X by 2. If we little bit rearrange this one, we can write down 1/2 F times X, and here we have 1 by 2. If we look at energy stored in this spring, we can simply say EP. This will be equal to 1/2 F times extension, that is X. So this is X. So it means this is representing EP. So this is EP. So we can simply write on here. We have EP times 1 by 2. Half of EP means the elastic tension energy in these two springs is half of the energy stored in this one spring. So this is value of nu EPE. So we can also write on here EPE nu. So this one is half. So this is important. And extension in each spring is also X by 2. Mean extension of this arrangement is X by 2. So we can find out our answer. If you look at A, extension is X by 2. EPE is 1 EPE. This is EPE by 2. So EPE nu is a half of the EPE of single spring. So the answer for this one is A. So rest of the options, they are not possible.